In this lesson, we're going to continue to look at the new terms that we need to learn before we can learn how to perform calculations in chemistry. In the last lesson, we have already looked at three terms: relative atomic mass, relative molecular mass, and relative formular mass. So for this lesson, we're going to focus on the term of mole. So as always, we're going to look at what is mole, why is it being used, and how do we obtain the value of mole. Alright, so firstly, what is a mole? Now a mole is actually a unit of quantity. Alright, so you're going to ask, what is a unit of quantity? I am quite sure this is not the first time you have encountered it. For example, when I say that you have a pair of socks, so how many socks do you have? It is 2. Right, if you have a dozen of eggs, how many eggs do you have? That will be 12. Alright, so pair and dozen are examples of units of quantity. So naturally you're going to ask, so what number does a mole represent? Okay, a mole represents 6 times 10 to the power of 23. Okay, this number you need to remember is given a special name, also it's called Avogadro's number. Alright, so that will naturally lead us to the second question: why do we need to define mole as 6 times 10 to the power of 23, such a large number? Right, why is it used? Imagine if right now I have 1 gram of a carbon atom, of a carbon solid, alright, in the form of, let's say, graphite. If I have 1 gram of carbon, how many atoms are there in there? Right, that would be about 10 to the power of 22 carbon atoms. Alright, so if in a case where I have 5.29 grams of carbon, how many atoms do I have? It's not going to be easy to manipulate when you have a very large number. So as you will see later when we perform chemical calculations, that by defining 1 mole to be 6 times 10 to the power of 23, we can actually convert the amount of substances present into much more manageable numbers for calculations. So to recap, a mole is actually a unit of quantity. So what quantity does it represent? It represents 6 times 10 to the power of 23. Alright, mole actually has a symbol MOL. Now please take note that if you have more than 1 mole, the unit is still MOL. Alright, not MOLS. Alright, an equivalent for this would be, for example, if I have something that's 1 kg, and if I have 2 times the mass, it doesn't make it 2 kgs. Alright, but it's still 2 kg. Alright, so essentially what do you need to remember for mole is this: that 1 mole of anything, alright, 1 mole of anything simply means that I have 6 times 10 to the power of 23 of that thing. If I have 1 mole of neon atoms, I have 6 times 10 to the power of 23 neon atoms. Okay, if I have 1 mole of water molecules, I will have 6 times 10 to the power of 23 water molecules. If I have 1 mole of sodium chloride, I will have 6 times 10 to the power of 23 formula units of sodium chloride. Right? Or in very daily life items, if I have 1 mole of cats, it simply means that I have 6 times 10 to the power of 23 cats. Alright, so I hope you get the idea. Now the last question: how do we obtain the value of mole? Alright, there are many ways. In fact, there are 4 ways that we're going to learn. Alright, so which way or which method do we use depends on what is given in the question. Alright, so we'll look at the 4 different ways. Now the first way of finding number of moles is based on the number of particles present. Alright, we have learned that 1 mole of a substance contains 6 times 10 to the power of 23 particles. Alright, so if I were to ask you now, how many atoms are there in 3 moles of helium? Right, how many atoms are there in 3 moles of helium? this is like a simple mathematics problem. Number of atoms, if I use capital N to represent, it will be just 3 times Avogadro's number. Okay, now the next question then, if I tell you that there are 2.7 times 10 to the power of 24 helium atoms, how many moles of helium atoms are there? Alright, again, it is like a mathematics problem. To find number of moles, right, I will use the symbol small n to represent number of moles. We simply need to take the number of particles divided by Avogadro's constant. Alright, for those of you who cannot see that, 1 mole of any substance has this value, 6 times 10 to the power 23. So we don't know how many moles, but we have this number of particles, 2.7 times 10 to the power 24. Right, so to find how many moles, we need to take the number of helium atoms divided by the Avogadro's number. Now from these two sample questions, I hope you can see how number of particles is related to number of moles. In fact, we can use a triangle to represent that, and the triangle looks something like this. Alright, now I'm going to use L to represent Avogadro's number. Okay, and then once again capital N to represent number of particles, and then small n to represent number of moles. Alright, so how do we use a triangle like this? It actually allows you to deduce the formula depending on what you want to find out. Alright, so for example, if I want to find number of moles, right, which is small n, so the formula is actually equals to capital N, a number of particles, divided by Avogadro's constant. Okay, so next, if I want to find number of particles, it will be equals to number of moles multiplied by Avogadro's number. Okay, we'll see more of such triangles later. So let's try the formula that we have just learned on this particular practice. How many hydrogen atoms are there in 0.5 moles of hydrogen chloride? Okay, so let's recap the triangle again. The triangle looks something like this. So here we are trying to find number of hydrogen atoms. So number of atoms equals to number of moles times Avogadro's constant. Alright, so number of HCl atoms is actually equals to number of moles times Avogadro's constant, which is equals to this. Okay, now in the next example, we have 1 mole of water. Alright, so please take special note of this question. So to find number of water molecules, same thing, we take number of moles times Avogadro's number. That will give us 6 times 10 to the power of 23 water molecules. Okay, but take note that the question is asking for how many hydrogen atoms are there. Alright, so if you still don't see it, let me give you an analogy over here. Now if I have a dozen cats, okay, how many cats do I have? I have 12 cats. Alright, but if I were to ask you how many eyes are there in a dozen cats, right, for that you need to recall, you need to tap on the knowledge that each cat has 2 eyes. Alright, so number of eyes in a dozen cats will be 12 times 2. Okay, now what we have just found over here, the number of particles, is for water molecules. Now if you were to look at the formula of water, each water molecule is actually made up of 2 hydrogens and 1 oxygen atoms. Okay, so the number of hydrogen atoms present will be equals to 2 times the number of water molecules present, which will give you 12 times 10 to the power of 23. Alright, and the last example over here, 0.1 mole of ammonia. Alright, so number of moles of ammonia, number of particles or number of molecules of ammonia will be equals to number of moles times Avogadro's constant. So that will give us 6 times 10 to the power of 22. Alright, but once again, each ammonia molecule is made up of 1 nitrogen and 3 hydrogens. Alright, so if we have 6 times 10 to the power of 22 ammonia molecules, the number of hydrogen atoms present will be 3 times that of the number of molecules. Okay. Now we're going to look at another method to obtain number of moles. Alright, previously we saw if you are given number of particles, we can actually divide the number of particles by Avogadro's number to get number of moles. So right now we're going to learn another method. In this method, if we are given the mass of a substance, we can actually find number of moles. And how do we do that? We need to first define another term. Alright, this term is called molar mass. Alright, again, what the term means can be inferred from the name. Molar usually means for 1 mole of the substance. So molar mass means the mass of 1 mole of the substance. Alright, how do we get the value? The value of molar mass, alright, is actually the same. It has the same value as your relative atomic mass or your relative molecular mass. Alright, what I mean by that is that if I have 1 mole of an atom, alright, it will have the same mass as the relative atomic mass of the atom. Yeah, if I have 1 mole of a compound of a molecule, it would have the same value of mass as the relative atomic mass of that molecule. Alright, but the difference is by the way we define molar mass, the mass of 1 mole of a substance, it actually has a unit because it's not relative, it's not compared to anything. Alright, so the units for molar mass will be grams per mole. Alright, take note, grams per mole. Alright, so if you recall, let's go back to a few relative atomic and molecular masses that we have seen. So for example, CO2, ammonia. Alright, for relative molecular mass, we simply need to sum up the atomic masses for all the atoms. So you will get 44 for carbon dioxide, and then you will get 17 for ammonia. Alright, so what is the molar mass for these two substances or these two molecules? It has the same value, just that now there is a unit. The molar mass for carbon dioxide is 44 grams per mole, and the molar mass for ammonia is 17 grams per mole. So how then can we use molar mass to find number of moles is this. Alright, so in this mathematical problem, hydrogen has a molar mass of 2 grams per mole. So again, what it means is that 1 mole of hydrogen has a mass of 2 grams. So what is the mass of 10 moles of hydrogen? So mathematics problem, 1 mole of hydrogen weighs 2 grams. 10 moles of hydrogen weighs how many grams? Alright, so the mass of hydrogen will be equals to 10 times 2. Alright, which is the number of moles times the molar mass. Alright, so I'm going to use capital M to represent molar mass. There's a slight difference between this and relative molecular mass, so I'm not going to use the same symbol to represent the two terms. Okay, so next question, given 4 moles of carbon has a mass of 48 grams, what is the molar mass of carbon? Now assuming that you don't know the molar mass of carbon, alright, but they tell you that 4 moles of carbon has a mass of 48 grams. What is the molar mass? So molar mass simply means the mass of 1 mole, and to find molar mass we simply take 48 divided by 4, which is equals to 12. So essentially molar mass is the mass divided by number of moles. Alright, so from these two questions again we can see the relation between number of moles, mass, and molar mass. Okay, so I'm going to illustrate again how to use this triangle. If you want to find number of moles, the equation is mass divided by molar mass. Okay, if you want to find mass, is equals to number of moles times molar mass, and so on. Now let's use the formula that we have just learned to practice again on a few questions. So I'm going to draw the triangle once more. In this question we're supposed to find the mass of 2 moles of water. So mass is equals to number of moles times molar mass. 2 times the molar mass of water is 18, so it's 36 grams. Okay, next 0.5 moles of carbon dioxide. Again, mass equals to number of moles times molar mass, which is equals to 0.5 times 44, which is 22 grams. Okay, and lastly I have 0.1 mole of oxygen gas. Now in this question it is on purpose that I do not write the molecular formula of oxygen gas. Alright, why is it so? It's because when students see oxygen gas, very often they fail to register, or they fail to recall that it's a diatomic molecule. That means when we say oxygen gas, it is O2 and not O. Okay, so very frequently when students see oxygen gas, they will just take 0.1 times 16. Alright, but oxygen gas is a diatomic molecule. Alright, so the molar mass is 16 plus 16, which is 32, and the mass is 3.2 grams. Now this is a slightly different question. Now you're given the mass of the substance and you're supposed to find number of moles. So let's draw the triangle out again. So now we are trying to find number of moles. Number of moles is equals to mass divided by molar mass. So in the first example I have 6 grams of carbon, so number of moles of carbon is actually equals to 6 divided by 12. Alright, and then second question, number of moles of sodium is equals to mass divided by molar mass, which is 23. Alright, if you look up the periodic table, sodium has a relative atomic mass of 23, so that would give us 3 moles. And lastly, 5 grams of magnesium oxide. So number of moles of magnesium oxide is equals to mass over molar mass, which is 40. Alright, and that will give us 0.125 moles. So from these calculations, I hope you can see that when we express masses in terms of relative masses, in terms of molar masses, and when we express amount of a substance in terms of mole, the numbers become very much more convenient to handle.